Hi everybody. In my last video, I showed you the first method for solving systems of equations. We solve them by graphing. Now I'm going to show you one of the algebraic methods. We're going to solve by substitution. The other way is to solve by elimination. That's not something that I typically teach in my advanced 7th grade class. Usually I just introduce systems. We do graphing and we do substitution, and then they learn more about the elimination method the following year. So let's focus on substitution. Substitute means replace. My students have done this before. It just looked a little bit different. But back in the day, I had you evaluating expressions. I would give you an expression, a math problem, and then I would tell you what to replace the variable with. You'd plug it in, you'd do the math, and bada bing, bada boom, there's your answer. We also did it when we graphed with tables. You pick values for x, you plug them in, you see what you get for y, that becomes your point. For example, if we have the equation y equals 4x minus 1, and then I tell you that x is 3, then all you do is you take that value for x and you plug it in. So this would really be 4 times 3, which is 12. 12 minus 1, y would equal 11. If y equals negative 2x and I tell you that y is 6, so then you put that in place of y, and then you're going to solve it for x. So to get x by itself, I would divide both sides by negative 2. And I would find out that x is negative 3. So it's that same kind of idea that we're going to use. The difference is it won't just be a single number value. It's going to be another expression that you're plugging in. So here's my first system. These two equations are a system because they're existing at the same time. I want to find the value of x and y, that combination, the coordinates for a point that work in both systems at the same time, or both equations of the system at the same time. So you want to make sure that in one of your equations, you have one variable by itself. The ones that we're focusing on right now that I do with my 7th graders in the advanced class, I already have one set up that way. In this case, both equations have a y by itself. So what you're going to do, I'm just going to start with the second equation. You're going to take that expression that it says y equals, and you're going to replace y in the other equation with that expression. Okay? So here's what I mean. That top equation, instead of saying y equals, I'm going to say this thing. I'm going to say 2x equals x minus 3. So it's the same equation that we started with. It's just instead of writing y, I wrote this expression that y equals in my other equation. So now I've got a complete equation that's only in one variable. I'm going to solve it for x. So I'm going to subtract an x from both sides, and I find out that 1x, or x, equals negative 3. There's the first part of my answer. The value of x is negative 3. Now to get the second part, we've got to find y. So we're going to substitute again. It doesn't matter which equation you use, just pick one. And you're going to take that value for x, and you're going to plug it in for x, and then solve it for y. I just randomly picked the second equation. Honestly, there was no reason. I just did. So I'm going to write y equals, instead of saying 2 times x, I'm going to say 2 times that value that I got, negative 3. So y equals negative 6. There's the second half of my solution. Now, if you're afraid that you haven't done something right, the best thing to do is to plug those in and check. I'm going to take my first equation, y equals x minus 3, and I'm going to substitute those values in. So I'm going to say negative 6 equals negative 3 minus 3. That one works. That one's good. Then I'm going to take my second equation, y equals 2x, And I'm going to plug in the x and y. So negative 6 equals 2 times negative 3. That one's good. As long as it works in both equations, then that must be the solution. We're going to do a few of these. So if that was like clear as mud or like in a different language, don't panic. I think it's going to get better. Okay, let's look at the next one. So you want one of the equations at least to have a variable by itself. Both of these are already solved for y. So what I'm going to do is I'm going to replace or exchange the y in one equation with that expression from the other. So I'm going to rewrite that top equation, but instead of saying y equals, I'm going to say 3x equals. And then write the rest of it, x minus 6. So all I did was I took that top equation, I pulled out the y, and I replaced it with the 3x from the second equation. So now I'm going to solve this. I'm going to get my x's together, so I'm going to subtract an x from both sides. That leaves me with 2x equals negative 6. I'm going to divide both sides by 2, and I get x equals negative 3. There's the first half of my solution. To get the second half, I'm going to take one of those equations, and I'm going to plug in the x and solve it for y. I'm just going to use the second one like I did in the first example. So y equals, instead of 3 times x, I'm going to say 3 times negative 3. And that tells me that y equals negative 9. There's the second half of my solution. If you want to make sure you're right, take that ordered pair, that x comma y, and plug it into your equations. So my first one would say, instead of y equals x minus 6, it would say negative 9 equals negative 3 minus 6. That's good. The second equation, instead of y equals 3x, it would say negative 9 equals 3 times negative 3. That one's good. So I know that solution is correct. I think I've got about 3 more. Okay. Now, on this one, they don't both say y equals, but you really just need to make sure one equation has one of the variables by itself. There's no reason to do extra work. I'm going to take this expression and I'm going to replace y with it in the other equation. So I'm going to rewrite that second equation. I'm going to say 8x plus, instead of 4y, it's 4 times this whole expression. So parentheses are important. I'm pulling out the y and I'm replacing it with 3x plus 8. And then it says equals 12. This is exactly the same equation as this. I just pulled out the y and replaced it with this expression. Okay, so now this is a multi-step equation. I need to do my distributive here. So this says 8x plus, that becomes 12x plus 32 equals 12. I can put these two together. They're on the same side of the equal sign, so do the same operation that you see. Just combine your like terms. So really on the left, I have 20x plus 32 equals 12. I'm going to subtract the 32, and that leaves me with 20x equals negative 20. I'm going to divide both sides by 20, and I find out that x has to be negative 1. There's the first part of my solution. Now to get the second part, I need to solve for y. You can plug it into either equation, but it makes so much more sense to me to plug it into the first because I want to know what y equals, and that already says y equals. So y equals 3x plus 8, but instead of x, I'm going to put in negative 1. So y equals 3 times negative 1 plus 8. That would be y equals negative 3 plus 8. So y equals 5. There's the second half of your solution. And like we did on the others, you can always plug that back in and make sure that it really does work in both equations. Couple more. Y equals 2x plus 1, and then 3x plus 4y equals 26. Again, I don't need both equations to have a variable by itself. I've already got y by itself in that first one, so I'm going to take that expression for y, and I'm going to put it in for y in my other equation. So I'm going to rewrite that second equation as 3x plus 4, instead of times y, it's times this whole thing, 2x plus 1, and then equals 26. I'm going to do my distributive. So this becomes 3x plus 8x plus 4 equals 26. Again, combine your like terms. They're on the same side of the equal sign, so do the same operation that you see. So that's really 11x plus 4 equals 26. I'm going to subtract the 4, and that leaves me with 11x equals 22. Divide by 11, and I find out that x equals 2. So there's the first half of that solution. To get the second half, I'm going to plug that answer for x back into an equation. It's going to make the most sense to plug it in the first one because I want to know what y equals, and it already says y equals. So this would say y equals 2x plus 1. That's going to become y equals 2 times, plug in your answer, 2 plus 1. So y equals, that's 4 plus 1, which is 5. So my solution is 2, 5. Last one. I've got one equation that has one variable by itself. That's all I need. I'm going to take this expression and put it in for y in the other equation. So I'm going to rewrite that top equation as 2x plus 5 times that whole thing, 6x minus 4, equals 44. Need to start simplifying, so do your distributive. That becomes 2x plus 30x minus 20 equals 44. These two can go together and become 32x minus 20 equals 44. I'm going to add 20. So that gives me 32x equals 64. I'm going to divide both sides by 32, and I find out that x has to be 2. So there's the first part, x is 2. To get y, you're going to plug that back in. Again, I want to know what y equals, so I'm going to plug that into the one that says y equals. So y equals 6x minus 4 really means y equals 6 times 2 minus 4. So y equals 12 minus 4 is 8. Okay, that is solving systems by substitution. Thanks for watching. I hope it helped. Subscribe or reach out if there's anything else I can do. Until next time, thanks so much. Bye.